So continuing with our problem here. So if Ma'am Francesca takes 1.5 feet per pace and she had 25 pieces to reach point B from point J, okay, so she's on point J and she needs to reach point D. Okay, so what is the width of Pasig River? What is the width of the Pasig River? So we have already what do you call this? We've already established that JD, okay, so line segment JD is the same as line segment JR. Therefore, if we get the measurement of JR, we also get the measurement of JD. Other way around. If we get the measurement of JD, we get the measurement of line segment JR. And line segment JR is the width of the Pasig River. Okay, so to get that, okay, so simple mathematics or arithmetic. Okay, so that's going to be 25. Okay, so let's write that down. Okay, 25. Okay, so that's simply going to be 25 times 1.5. Okay, so that's 1.5. And 25 times 1.5. Okay, so that's going to give you 37.5. Okay, so that means that the Pasig River's width is 37.5 feet, since Ma'am Francesca walked from point J to point D, and that's 37.5 feet. And since JD is congruent to JR, or is equal to JR, so therefore the width of Pasig River is also 37.5 feet. Okay, so for our next problem, we're going to be solving a bit of a tricky problem here. So we're given here a big triangle FRN, and it has 4 triangles inside of it. So it has triangles FOT, ROU, TON, and UON. Okay, so given that ON, line segment ON, is the perpendicular bisector of FR, and ON also bisects TOU, angle TOU. So we need to prove that these two line segments, TO and OU, are congruent. Okay, so it might look a bit difficult, but if you plan ahead, okay, so if we plan ahead, the main attack or the main direction that we can try to get to in order to prove that these two line segments are congruent is we can use Cpctc, or again, that's the congruent parts of congruent triangles are congruent. Since we're talking about here segments and they are essentially part of two triangles, so we can prove first that the triangles are congruent, and from there we can prove that the parts of the triangles are congruent. Okay, so let's start with the proof. Okay, so again, as with all proofs, we start with the given. Okay, so the given here, okay, so what's the given? Okay, so we have here ON is the perpendicular of bisector FR, okay, and ON also bisects angle TOU, and that's a given. Okay, so for our second statement here, okay, we can say that for our second statement, we can try to look back on the figure. Okay, so there's a given that ON is a perpendicular bisector. And again, guys, what do perpendicular bisectors do? They divide a line segment into two congruent segments, two smaller congruent segments. So if we have here line segment FR and it's been bisected perpendicularly by line segment ON, then we can say that FO and FR are congruent. Okay, but first we have to establish, okay, the point O is the midpoint of FR. Okay, so it's the midpoint of FR, given that the reason here is it's the definition of a midpoint, or the definition also of a perpendicular bisector. Definition of a perpendicular bisector. Okay, so we have these two statements. So the third statement that we can introduce here would be FO. Okay, line segment FO is congruent to line segment OR. So FO is congruent to segment OR through the definition of a midpoint. Okay, so let's write that here. Okay, so we can have that as FO is congruent to OR, Okay, and the reason for that is a definition of a midpoint. Okay, so let's just arrange our statements and reasons here. Okay, so we have here now our fourth statement. Okay, since it was stated that ON is a perpendicular bisector, we can say that FON and NOR are right angles. Is that right? Okay, so FON and NOR are right. Okay, so let's write that. Okay, so that will give you 4 FON and NOR are right angles, and the reason for that is the definition of perpendicularity. Because since they are perpendicular lines, therefore they must have a right angle, or there must be a right angle relationship between those two angles. Okay, FON and NOR. Okay, so the plan here is we wanna try to find, or we wanna prove that triangle FON and triangle NOR are congruent. Okay, so to do that, we need just one final statement, so that will be ON. Okay, line segment ON is congruent to line segment ON, so ON is congruent to ON, and that's just simply again the reflexive property of congruence. Okay, and from here, since we've established that FO is congruent to NR, so FO is congruent to OR, and so FO is congruent to OR, and we have ON is congruent to ON, and then the angle, okay, the angle here, okay, the included angle here, using the ASA triangle congruence postulate, both of those angles are congruent since they're right angles. Then therefore, through the ASA triangle congruence postulate, we can state that, okay, triangles, okay, let's go back here, FON and RON. Okay, triangles FON and RON are congruent. Okay, so they're congruent because of the so they're congruent based on the SAS. Okay, SAS triangle congruence postulate. Okay, because we have both sides, okay, two consecutive sides and an including angle for both triangles that are congruent, okay, and corresponding. So we have that reason for, or the proof there for those two triangles. Okay, and then for number 7, okay, since we've established that triangles FON and triangles RON are congruent, okay, so we can say that their congruent parts are congruent. So one of the parts that both of these triangles that are congruent that we can use for this problem is this side, specifically this side. We can use side FN. Okay, we can use side FN to prove that, okay, to prove or to contribute to the proof for solving the last proof of our problem here. Okay, so for number 7, okay, we can write, here for number 7 that triangle ONF is congruent to triangle ONR. Okay, so they're congruent because of congruent part of congruent triangles, since we've already established that OFN, FON, and RON are congruent. So that's ONF and ONR. So let's write that. So number 7, ONF and ONR. Okay, so let's just write it very neatly. Are congruent angles. So since they're congruent angles because of Cpctc, or congruent part of congruent triangles are congruent, since we've already established that. Okay, so let's write for number 8. Okay, since we know, since we already know that ON, line segment ON, also bisects angle TOU, so that must mean that angle TON and angle UON are the same. Okay, so those two angles are the same because they have been perpendicularly bisected by line segment ON. So let's write that. Okay, so we have here as our eighth statement, we have here triangle TON and triangle UON are congruent. Okay, angles. Okay, so let's write that neatly here. Angles TON and OUN. What's that? TON and UON. Okay, triangles TON and angles TON and angles UON are congruent. So they're the same. Okay, because that's the definition of a perpendicular bisector. Okay, because they were bisected. Okay, so or simply a definition of a bisector, since a perpendicular bisector is just an example of a bisector. Okay, and from there we can say also we've already proven that ON is equal to ON through reflexive property of equality, and therefore for number 9 we can write here. Okay, that triangles EON and triangles UON are congruent. Okay, so we've proven the angles are congruent. Okay, it's now time to prove that the two triangles are congruent. So triangles. Okay, so let's write that neatly here. Okay, so it's going to be triangles TON and UON are congruent. Okay, so they are congruent because of the ASA, or the angle side angle. ASA or the angle side angle triangle congruence postulate. Okay, so they're congruent because of this theorem that we have here. So how are they congruent using that theorem? Okay, so we've already proven that this angle TON is congruent to angle UON because that's a given, it's a perpendicular bisector. And also we have here angle ONF. Okay, angles ONF. Okay, angle ONF is congruent to angle ONR because we've already proven that those triangles are congruent, and therefore Cpctc, congruent parts of congruent triangles, the two angles are congruent through Cpctc. And we have here the side measurement. Okay, so the side measurement, which is ON, so that's ASA triangle congruence postulate, the angle. Okay, so this angle here, the side, the side measurement here, and also the angles that we have here. Okay, so there you go. Okay, so we have those angles, and now we need to continue with our proof. So since we've established that TON and UON, those two triangles are congruent, therefore we can say, finally we can say with confidence, number 10, that what we want to prove here, TO is congruent to OU, or UO. Okay, so that will give you TO is congruent to OU. Okay, so let's just write that neatly. Okay, here. Okay, so the reason for that again is none other than Cpctc. Okay, so there you go. So the concurrent parts of congruent triangles are congruent.